Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic, using the unit circle. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit me on my Facebook page, Tutor Me Sempai, and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics, so if you're interested in that, make sure you stay tuned. This video is going to have 5 parts, so leave a like, smash subscribe, and let's get started! Before we jump into actually using our unit circles, there's 4 really quick things that are good to know when trying to use your unit circle. And the first thing is going to be the fact that there are actually 3 unit circles. You have your degree unit circle, you have your radian unit circle, and you have your value unit circle. Now, if you have no idea what a unit circle is, or you don't necessarily remember how to fill in your unit circle, no worries. I have a video talking about just that you can find right up here. It's a full-length video that talks about each of the 3 unit circles and how you can use patterns to fill in, so you don't have to memorize the entire thing. You can fill in the rest once you know your first quadrant. So check that out, understand what your unit circle is and how you can fill it in, and then come back to this one so you can see how you can then use your unit circle. And this leads us to our second good to know point. Whenever you're evaluating your trig function anywhere on the degree unit circle or the radian unit circle, the result is going to lie somewhere on the value unit circle. So evaluating on the degree or radian unit circle gives you something on the value unit circle. Now this leads us to our third good to know point, the value unit circle. How do we read our value unit circle when it comes to our trig functions? Now, whenever we have a point, we have an x coordinate and we have a y coordinate. So when you have a point, you're typically going to write your x coordinate first and then your y coordinate second. However, when we have our value unit circle, we need to understand how we can read that with our trig functions, our sines and our cosines. What I'm going to tell you is going to be this way. You're going to write it with cosine first, cosine of something, sine of something. So every point on your value unit circle is going to have a cosine in the x coordinate and a sine in the y coordinate. That's how you can read your value unit circle. Now, how do you remember this? Well, an easy way to remember this is, look at this. X comes before y. Well, X comes before y in the alphabet, right? X, Y, Z. So X comes before Y in the alphabet. Therefore, X comes before Y in your point. C comes before S in the alphabet. So therefore, cosine comes before sine in your point. So that's going to be a really easy way to remember cosine before sine. Cosine is always going to be that very first number in your point on your value unit circle. Sine is going to be that second one. And last but not least, our fourth good to know point is going to be the fact that tangent, our trig function tangent, is going to be equal to sine over cosine. So the sine divided by cosine. That's what tangent is. So our fourth good to know point is that tangent of something is going to be sine of that same something over cosine of that same something. So once you have these 4 good to know points down, using your unit circle is going to be a breeze. So let's jump straight into our first example for today. So our first example for today is going to be sine of 210 degrees. We want to try to figure out what the sine of 210 degrees actually equal. Now, if you have a unit circle, whether it's been given to you or you've had to create it, great. I'm going to put a unit circle right over here that we can reference as we're going along with these examples. So follow along on your unit circle if you have one. Now, sine of 210 degrees. We want to look at 2 different unit circles. We want to look at the degree unit circle and we want to look at the value unit circle. You're always going to look at the value unit circle because that's where we're trying to go. But your first circle may be different depending on where you're starting. We have a degree here, so we're going to be looking at the degree unit circle. So 210 degrees. If we look at unit circle, what is the value point that is on that same exact line? Well, the point is going to be negative square root of 3 over 2, comma, negative 1/2. So that's the entire point. But sine is not going to be this entire point. Remember what we talked about. which one of these values is going to be the sine value? Well, if x comes before y, c comes before s. So that means that our sine is our second one. So since sine is the second one, our value is just going to be -1/2. That's all we have to do. We look at our degree unit circle, figure out what line we're on, compare that to our value unit circle, find the point, and then depending on what trig function we're looking at, we know whether we're looking at the first or the second one. Because we're looking at sine, we're looking at the second one, and that's going to be our value. Sine of 210 degrees is simply -1/2. Let's move on to our second example for today. So for our second example for today, we're going to be looking at cosine of 3 pi over 4, and we want to figure out what does that equal. Now the two unit circles that we're going to be focusing on now are going to be the radian unit circle and our value unit circle. Since there's no degrees here, we're not going to be looking at the degree unit circle. It's now radians because that's what we're plugging into our trig function, and of course our value unit circle. So we're going to do the same exact thing. Let's start with our radian unit circle, find the line, and look at what point that corresponds to on the value unit circle. So at 3 pi over 4, if we look at our value unit circle, and once again you can reference yours or one up here, we see that the point on the value unit circle is going to be negative square root of 2 over 2, comma, square root of 2 over 2. Now, which one of these corresponds to the cosine value? Remember, x comes before y, so c comes before s. C is before s, so cosine is the first one. That means our answer is just going to be negative square root of 2 over 2. Cosine of 3 pi over 4 is going to be negative square root of 2 over 2. Let's jump into our third example for today. In our third example for today, we're going to be looking at tangent of 11 pi over 6. And we want to try to figure out what that equals. Now, which two unit circles are we going to be focusing on? Well, because we have radians here, it's going to be the radian and the value. Once again, no degrees, so we don't focus on the degree unit circle. So we're going to start off the same exact way. We're going to look at the radian unit circle and see which point on the value unit circle corresponds to the same line. So 11 pi over 6, if we look at our unit circle, we see that the point that corresponds to on the value unit circle is going to be the square root of 3 over 2, comma, -1/2. Now, which one of these is going to correspond to tangent? Now, we said x comes before y, therefore c comes before s. But this is neither cosine nor sine. So how does that help us? So what do we need to do to figure out what tangent of 11 pi over 6 is? Well, remember, tangent of anything is going to be sine of that same thing over cosine of that same thing. So we can rewrite this as tangent of 11 pi over 6 is going to be sine of 11 pi over 6 divided by cosine of 11 pi over 6. So now that we've written this out like this, all we have to do is figure out what is sine of 11 pi over 6 and what is cosine of 11 pi over 6 and divide them accordingly. So sine, now we just said before that x before y, therefore c before s. I'm going to keep saying that to kind of drive it home. X before y, therefore c before s. So sine is our second point. So sine of 11 pi over 6 is going to be -1/2. And we're going to divide that -1/2 by the square root of 3 over 2. So this is what that equals. Now we can simplify this. And we know that whenever we divide two fractions, we're really just multiplying by the reciprocal. So let's rewrite this, multiplying it in a way that makes sense for us. So this is going to be -1/2 times 2 over the square root of 3, the reciprocal of this first value. And when we multiply this across, we're going to end up with -1 over the square root of 3. Now, typically we don't keep radicals in the denominator. So you would write this over by multiplying top and bottom by the square root of 3. So it really would be something like this. Times the square root of 3, top and bottom. So you would get a negative square root of 3 over 3. And this is only because we don't typically write radicals in our denominator. We don't really like having an irrational denominator. So we make our bottom rational by just doing top and bottom by that same radical. So now that we've effectively divided sine by cosine, we know our final answer to be this. So tangent, going back to up here, tangent of 11 pi over 6 is simply going to be negative square root of 3 over 3. Now this was square root of 3, so I can read it. Negative square root of 3 over 3. This is going to be our answer. So let's look at one more example, but this one's going to be a little bit different. This one's going to be our bonus example for today, in which we're going to do the reverse. So we went from degrees and or radians to value, but we can technically go from value to either degree or radian depending on what we're trying to do. So for our last example for today, we're going to be doing the reverse. We're going to have a value, but try to figure out what our theta is. In this case, we're going to be looking at degrees. So we know that we have a restriction here because we have repeats when we have our values, right? We repeats depending on where we are, first, second, third, or fourth quadrant, you're going to have the same type of value. So if you don't have this restriction here, you're not going to be able to know where you're going to live, which quadrant you're supposed to be in. So we need to have your restriction when you're trying to go backwards, unless you're just trying to figure out all the possible thetas. But we want a very specific theta, so we're going to look for the theta that's between 0 and 90 degrees. Pretty much, what's the theta in our first quadrant that when we plug it into cosine, we're going to get 1/2. So the two unit circles we're looking at, this time we're going to be the value unit circle as the first unit circle and our degree unit circle. So we're going to look at our value unit circle, and we know that we're at 1/2. So what is going to be our degrees in our first quadrant when cosine is 1/2? Now remember, x is before y, so c is before s. Cosine is your first value. So if we look at our unit circle, which line has 1/2 as the first value? Well, it's going to be the line that has this point, 1/2 square root of 3 over 2. Now if you look at the degree unit circle, which line corresponds with the line that pointed to this point? Well, that's going to be 60 degrees, because remember, we're looking at the first quadrant. So in the first quadrant, the line that corresponds to this point on the degree unit circle is going to be our 60 degree line. So we know that this theta is going to be 60 degrees. But because we have this and it's in the restriction, it's a good sign that we did this correctly, and we see that we can go from value to degrees just like we could go from value to radians. But this is going to be how you can use your unit circle. So I hope you were able to follow along with today's examples, and I hope you now know how you can use your unit circle. However, if you have any questions about what we saw today or even on homework, you can always put it in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so can someone else. So leave a like, smash subscribe, hit that notification bell, and make sure you share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, that's your playlist, and this has been another session of Tutor Me Sempai.